Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video we understand the concept of pass by value versus pass by reference in C programming. So before we begin, it is a request to please subscribe to my channel. We discuss what is pass by value and what is pass by reference in C programming, and in previous videos about pointers and C programming we saw what are pointers. Okay, pointers are basically variables that hold a value, and the value that they hold is basically address of a memory location. Then we saw how this concept applies to array pointers, how this array variable is also a pointer to the first location of the array. All right, and in this case we do pass by value versus pass by reference. Okay, so the concept here is to discuss how values are passed to functions, okay, when a function is called, right? So example, if I have int k equal to say 10, okay, and if I write a function void add 2 that takes an integer say m, okay, and I say printf m in add 2 %d backslash n, okay, just to print the value of m in add 2, okay. Then adding 2 to m in add 2 after adding 2, okay. So this is going to be whatever value of m plus 2, okay. So when I pass this integer k to this function add 2, okay, right, we get the variable m gets the value whatever is stored in k, which is 10. You print 10, you add 2, you print 12 again, okay. ECC pass minus o pass, okay, slash pass, okay. So m in add 2 is 10, m in add 2 after 2 is 12, okay. So this what we call is pass by value, that the value whatever you are passing, a copy of that value is created, okay, and the original value remains unchanged, okay. So if I print k in main, which is this value k, and k in main after calling add 2, after add 2, okay. So the value of k remains unchanged, okay, because you are passing a copy of the value of k. So you have k in main, then this function call happens in which we have to print statements, and k in main after add 2. So k in main before add 2, k in main after add 2 remains the same, okay. Now what happens behind the scenes? So if you remember in my previous videos I told you that when you have something like int k equal to 10, the compiler reserves a memory enough to store an integer because this variable is of type int, right? So it says this memory has the value 10, this is a variable k, all right, in int of type int in function main, okay. This has value 10, okay. When you are passing this variable to another function, you have this function, whatever variables that you pass in this function or whatever local variables you create in this function will get their own separate memories, okay. So function call basically goes into activation record. We are not going to go there, we just think in terms of memory, okay. So you get another memory location, okay, capable of holding an integer because you get an int type m. The name of this variable is m of type int in function add 2, okay. And the value that this int m gets is the value which is passed here, a copy of the value stored in the variable k, a copy of 10. So this also gets 10, okay. So when you do print f m in add 2, so if this is your console output, okay, your first line of output was k in main, which is k, which is you print 10, okay. Then you print m in add 2, you print m, which is 10 again, you add 2 to m, all right. So this variable m now becomes 12, okay, and then you print 12, which is printed, and then you go back to this function, okay. Your control comes here after the function returns, okay. When the function returns, all the local variables that were declared and initialized in this function are gone, okay. So this is gone, okay. There is no more m and there is no more corresponding 10 to this, okay. And when you print k in main after 2, which is 10 again, so you get 10, okay. This is pass by value, that you're actually copying the value of this variable and passing it to the function, okay. Pass by value, okay, we say all primitive values are passed by value, okay. So if you're passing a double, if you're passing a float, a copy of that variable is passed, okay. The idea of saying this is that this k will remain unchanged because the copy of k is passed, the original k remains unchanged before and after the function call. Okay, so then what is passed by reference? Okay, arrays are passed by reference. Okay, so if I create an array something like this, int arr1, okay, say 1 2 3 4 5. Okay, if you remember in my previous video where I told you about array pointers, when you do something like this, you get memory enough to hold 5 integers together. You get one single chunk of memory, one single strip of memory, contiguous memory, for as many integers you are passing in this curly braces. So they have 5 integers, so you reserve memory for 5 integers, okay, which have values 1 2 3 4 5. Okay, and this variable arr1 is basically storing the address of the first location of this. So if this address is say addr1, arr1 is an int pointer, okay, storing the address of the first location addr1. It means it is pointing to this array. So this variable arr1 is storing the address of the first location of this array. Okay, that's why in order to go to the second location, you do arr plus 0, plus 1, plus 2, plus 3, plus 4. Okay, very detailed, explained in detail in my previous video. Okay, so if I write another function, okay, void add2, okay, and I say int arr and int n, okay, and I add 2 to all elements of this array that this function is accepting. Okay, for int I equal to 0, I less than n, I plus plus. Okay, we say ar of I plus equal to 2. Okay, right, we write another function to print the array. Okay, so we have this function to print the array, so I'll say print the array before function call. Okay, I am going to change a line so that we have a separator here. Okay, we say printf before add2, we print this array, print array, and I say arr1, and how many values? We have 5 values. Okay, in C programming, whenever you are passing an array, you also pass the size of the array. Okay, because unlike in Java where you can do dot length, we don't have that in C. Okay, so before add2 and then print array, then we call, okay, so you cannot have method overloading in C, so you say add2 say array. Okay, so I will call, okay, add2 array and pass arr1 and 5. Okay, and then before we print, then we call add2, then after add2, after add2. Okay, all right, so before we call add2 array, we get the value 1 2 3 4 5 in our array. After we call add2, which is adding 2 to each value in the array, the original array contents are changed and 2 is added to each element of the array, so it becomes 3 4 5 6 7. Okay, all right, so when I compile and run, so before you see 1 2 3 4 5, after it is 3 4 5 6 7. Okay, so arrays are passed by reference. Okay, that is the original copy of the array is passed. Okay, and I don't want to use the word original copy of the array because this is not entirely correct. The correct way of saying this is the reference to the array is passed. What do I mean by this is, okay, you have arr1 storing the address of this first location. Okay, when you call this function add2 array, okay, it gets its own variables arr and int n. So you have n, which is storing 5, okay, of type int, and in function add2. Okay, add2 array, the entire function name very long. Okay, this is n. You also get arr, okay, variable name is arr, okay, type is int pointer of function add2 array. Okay, so add2 array function gets this variable and this variable, and it gets the value which is in arr1 because you are copying the value of arr1 into this arr. Okay, so this stores addr1, this also will get addr1. This, since this is pointing to this location, this integer pointer is going to point to this location. So this arr that you are passing in print array is also pointing to the same original array, unlike the previous case where when we were sending this value of k, a copy of k was being sent, so a separate variable m was created. Okay, in this case addr1 arr is a separate variable, but it is still pointing to the same array. So the changes made to arr1 will be reflected back, which we are seeing in our output. Okay, so then what happens in the function is you add 2 to each location. Now arr is pointing to this array, you add 2 to each location, this becomes 3, 4, 5, 6, 7. When the function returns, we lose all the local variables, we lose this, we lose this. And arr1, which is storing this array, okay, it is still there. And the values are now 3, 4, 5, 6, 7, which is what we see in our output. Okay, this is what we call pass by reference. Okay, and I mean, watch this video till the end, because if you read enough about C programming, you will understand that this is also pass by value only, because you see, you are passing the address of the first location, which is a value which you are just copying into arr from arr1. This is also pass by value. The value that you are passing is the address of the first location of the array. Okay, but popularly this is called pass by reference. In C programming, you can say it is a simulated pass by reference. Okay, you can find good discussions about this on Stack Overflow, and I also believe that this is pass by value only. This is not pass by reference, but popularly it is known as pass by reference. And if you are in college, school, or if you're just appearing for interviews, you should stick to pass by reference. Okay, so in short, when you're passing arr1 to this function, the address of the first location which is stored in arr1 is copied into this arr. Okay, and you can simulate pass by reference using pointers. For example, if I have add to p, okay, add to p, now it takes an integer pointer k. Okay, and I say k in add to, and you say value at this, I'll make this kp so that I don't get confused. K in add to is value at kp, and value at kp plus equal to 2, you're adding 2 to this value, and then you're printing this again. Okay, kp in add to, k in add to after 2. Okay, so let me just change this line again. Okay, I will create a pointer to k. Okay, I'll say int p is address of k. So when you do this, you get another variable. Okay, the name of the variable is p. Okay, of type int pointer. Okay, it is a part of main function. Okay, and the value stored, it is the address of k. So if the address of k is, say, this address of this memory location is addr2, so this stores addr2. Okay, it means p is a pointer to k. All right, that's what we have done before. All right, and then you say add to p k. So add to p k, pass the integer pointer. Okay, and then we can print the values k before add to p. Okay, k in main before add to p, k in main after add to p. Okay, so since we are passing a pointer to k, we are updating the value which kp is pointing to. And when you are passing this this pointer p, the same address is being copied to kp. So kp is also pointing to k, just as p is pointing to k. All right, so changes made to kp will be reflected back in k. Right, so when I compile and run this, you see k will change. Okay, k in main before add to p is 10, then you call this function. Okay, where k in add to is 10, because the same values, the address to the same memory location is passed, where k is stored. You add 2 to it, and the changes are reflected back, unlike in the previous case. Okay, so what happens behind the scenes is you already have this in the main. When you call this function add to p, okay, it has one variable, kp, okay, is an integer pointer, okay, and has in function add to p. Okay, so when you are sending p, the value in p is copied to kp. All right, so value in p is addr2, so this also becomes addr2. So p was pointing to 10, so k, so this also points to k. All right, so you are creating another pointer which is pointing to the same variable k. Okay, when you print k in add 2, you get the same value 10. k in add 2 will give you the same value 10. Okay, then you increment the value at this location by 2, so you are saying make this 12. So the original k is changed because you are passing a pointer to k. Okay, then you print this, which is going to be 12. Okay, then the function returns. Okay, when the function returns, we lose all the variables in this function, so this is lost and this is lost. Okay, so the changes made to k are still there because we used a pointer to k, right? So when you print this again, k in main after add 2, now the k value of k is now changed to 12, so you get 12. Okay, this is not actual pass by reference. Okay, you can pass by reference simulated by using pointers. Okay, so we use this approach when we want the changes made to this variable, okay, in the function reflected back in the original function. In that case, we don't just pass the copy, all right, we pass the pointer to that variable so that whatever changes are made are reflected back in the original function. Okay, because I want these changes to be added to my original variable here. Okay, changes after the function call should be reflected back. This is the case when I just want to pass the copy of the variable. I don't want the changes made in the function reflected back in this original value. Okay, and arrays will be passed by reference. Okay, so we have int pointers here, float pointer, double pointer, long pointers will work the same way. Okay, you just have to be the pointer of the corresponding primitive type. Okay, same for this, all primitive values will be passed by value. Okay, whatever primitive value that you pass into double float. Okay, so let's do one more thing in my add to array. All right, I'm adding 2 to each value. I will say I will create arr 4 and I'll say 10, 11, 12, 13, 14. Okay, creating a fresh array in this function, and I'll say arr is now pointing to arr4. This is allowed. Okay, integer pointer pointing to this array variable, basically pointing to the same array. Then I do this and then I return. Okay, now you will see changes made here, okay, are to this array and not to the array which arr was pointing to, which is the original array here. Okay, so the changes will not be reflected back. So plus 2, which is being reflected back right now, will not be reflected back. So you see it is the same, because what is happening in this case is if you come here, right, in add to array. Okay, let me just create the variable same way here. So we were having arr. Okay, we were having arr, which is an int pointer in add to array. Okay, and we have n as well, so n is just 5. Okay, n is type int. All right, in add to arr. Okay, we create a fresh array arr4. So basically taking 5 locations 1 2 3 4 5 and putting values 10 11 12 13 14, creating a variable arr4, okay, which stores the address of the first location here. Okay, and then we say arr, which was pointing to this location. Okay, because we passed arr1 in add to array. Okay, which was pointing to this location and storing addr1. When we do this, it is now pointing to arr4. So this is lost and it is now pointing to arr4. Okay, so when you do plus 2 to each location, plus 2 to these are added, 14, 15 and 16. Okay, so when you print closing the function, let me just put this here so that it is visible to this function as well. I'll say printf arr4 before function returns. Okay, I'll say print array arr4. Okay, right, so you will see, okay, when you call this function, you print arr4 values which are 12 13 14 15 16 from 10 11 12 13 14, because plus 2 was happening on this, the way I have explained here. Okay, when the function returns, we lose this variable, we lose this variable, and this is also collected. Okay, we lose all this. Just Okay, yeah, all these were local variables, these are all collected, and our this original array remains the same. Okay, 1 2 3 4 5 only. So this was pass by value versus pass by reference. We basically simulate pass by reference for primitive variables by passing the pointers. When you pass array variables, you're actually copying the address of the first location in the variable. Okay, here. Okay, and as long as you don't reassign it, it will keep pointing to the original array. Okay, the location of which was passed. Okay, and when you're just simply passing primitive value, they are passed by values. Okay, and structs will also work in the same way. When you just pass structs, they are passed by value. When you pass struct pointers, they are passed by reference. Okay, you're simulating pass by reference. One final thing is, again, as I said before, there is nothing like pass by reference. It is all pass by value. But again, this is a very theoretical discussion, because even when you're passing the reference here, you're just copying the address of the first location into the variable that accepts the int pointer. Okay, all right, so we have done pass by value, pass by reference. We now move on to understanding how malloc works for dynamic memory allocation, so that we can start working on linked lists. Okay, so I hope this was helpful and you like this video. So if there is any doubt, is a part you don't understand, please let me know in the comments. I always try to answer all your comments. And you can also let me in the comments if the question you want to solve or the concept you want to discuss. Please like this video, subscribe to my channel, and thank you for watching.